Last time I smoked that extra credit.
I think I have to because I didn't really think about the second too much. I looked at it and I was like, wow, I really have no clue what to do with this at all.
I don't remember what it was. I know one of them was L up and down. I don't remember
Let me
what
tell.
the other one.
Okay. I cannot remember. Did we finish this one?
No. Come back to it.
Okay, why don't you start it or finish it for me, please?
You
No
had
time.
to finish it in order to leave.
Did I?
And you said,
What
you
you
said,
said-
you said you can't put yourself away unless you finish it. But then
I mean, I said let's go over it.
but then
okay.
you were like,
Oh, it's time to go.
sum up and you can leave.
Okay. What is the U on this? 5x squared minus 3. What's du? 10x what?
Just it.
dx. No, 10x dx. Don't forget your dx. It's part of the substitution process. Okay. So we'd like it to be 5. So I gotta cut it in half, right? So 1/2 du is equal to 5x dx. So when I replace, it's 1/2 and a du and a sine of u. Now, what's the antiderivative of sine? Negative cosine. So it's negative 1/2 cosine of u plus c. And then that is negative 1/2 cosine 5x squared minus 3 plus c. Yep.
If I wait to add my plus C on until the very end, that's not wrong, right? It's
Don't
just
care.
Process.
Just process. Okay. Questions on this?
Makes sense.
Why do they have stars by their name?
Because I wasn't 100% sure that they had done anything wrong, but I can take them off now. Well, they're deleting programs and resetting calculators, which irritates me because you people need them. Sticking freshman. Okay.
I think that's it.
Okay, try this one. This is a little sneaky here.
Can you pull a trig function up?
What is that?
Oh,
What is it?
got it.
Which is actually vital to this problem. So not only can you,
Yeah,
it's vital.
it's just not in the same way you would normally do it.
Right.
So you can't.
Like 1 over.
Oh,
yeah.
Oh, yeah, I'm doing it off with
We're trying to figure out the antiderivative.
I don't have that written down.
Actually, yeah, what's our
I guess I was busy talking to you because I'll put
Just have to rearrange the topics.
It turns into cosine.
Yeah, but does that take it to the top? Or does it just do?
Do the substitution first. If you're not sure, do your substitution first.
Because if you're dividing something by technically 1 under cosine, you can keep switching flip and move it to the top, right?
There's easier way to do it than that, but yes, that's fine.
Look, I just think about it. I don't actually do the keep switch flip. I just look at it and I know that. What way is easier?
Miles, these are exclamation points, not question marks, right?
Yeah.
They're not questions. Okay. Just making sure you didn't have questions that I
What's the
read.
derivative of 1 over secant?
Huh?
Well, the antiderivative of 1 over.
Okay, sorry. So you're talking about
that thing.
No.
Is there an antiderivative of 1 over secant?
No.
Just move the secant up. Garrett.
Well, I know what you're saying, but I wanted to see if I could do it the other way.
Think about it.
There is no other way.
1 over secant equals cosine.
Cosine.
So the derivative. So
So I could just say this is cosine.
So the derivative of it is the derivative of cosine because it is cosine.
Yeah. I'll show cosine. I didn't add. Yeah, don't add that.
I knew that.
Okay, so
You're just talking about this. You're like mine plus C.
talk to me about the inside function here. You guys, I love it when it's it's in parentheses like this. It's my first go-to. Like when you're like, hey, there's parentheses, that should be your first check for inside function. So du is equal to what? 10x dx. But I don't have 10x, I have 50x. So either pull out a 5 or multiply it over here. Either way, it's going to get the same. So you have 5. The top is what? 1. Or if you want to put the 5 there, that's fine. But you're going to have to pull it out anyway. This is du, and this is secant of u. Now, here's the deal with this one. I said it's a little sneaky. We don't know the antiderivative of secant, but use your brain. What is 1 over secant equal to? Cosine. This is actually cosine. So this is equivalent to the integral of 5 cosine u du. So really, 1 over secant is cosine. Got it. So that's why it's sneaky. What do you got to do? Or what's the antiderivative? Nope, positive.
It would be negative if you did the derivative or doing the antiderivative.
Correct. Sines and cosines are hard because like the negatives are flying around or like as backwards or forwards. So listen, always, because I do this, not that you are like me, but you know, I would hate to wish that anybody. Like I always check sine and it's in my brain. I go, okay, what's the derivative of sine? Cosine. So I did it right. Right. Then I can check to see if my negatives are right or not. Does that make sense? So just check. You guys, you can always check to see if you were not listening to what I was saying to Lily, especially with sines and cosines and the negatives that you're like, maybe I didn't do it right. Just check. The derivative of sine is cosine. So you did it right. Okay, no negatives involved there. Let's try bump it up a little bit here. Let's try this guy. So we have 36 x squared e to the 4x cubed plus 3 dx. No. Here's what I have to say. No parentheses, right? No parentheses. So there's no quote unquote obvious inside function. But you guys, what's the inside function? Yes, the exponent is the inside function because I don't have to have parentheses there. This is actually a significantly easy question once you get it substituted.
Is this just how we write it?
Just equals.
Oh, I don't care. There's no label to it though, really. Okay, so we said u is 4x cubed plus 3. What's du? 12x squared dx. So you go, oh, this is good because I have this. Now, I have not said this because sometimes I forget that you don't know all the things that are in my head. Of all the things that we're adjusting, notice that the only thing that we can do is mess with the constants. Okay? That's the only thing we've changed our numbers. You cannot be like, hey, I'm going to multiply both sides by sine, or I'm going to divide both sides by x. You can't do that. It's only numbers that you can adjust in your du statement. So if you're like, I can't adjust anything to make it work, then there's got to be another way to do it if you're being asked to do it. Okay? Which the only other way that we could do it is to expand some things. Doesn't apply to this question.
Does this only work for like a really specific set of problems that happen to have
Has to, it undoes chain rule.
Oh, so anything with chain rule would work for it.
Anything where the chain rule has been used, this is what's used to undo it. So this needs a 3, right? To be 36, so this is 3. So 3 integral of e to the u du. This is why I said this is actually really easy. What is the antiderivative of e to the x? E to the x. He's his own derivative and his own integral. So it's 3 e to the u, which I'm just going to write down. 4x cubed plus 3 plus c. I know. It looks like it's terrible. But that's the beauty of the u substitution is it makes your integral significantly simpler. Okay, so you guys okay so far?
Yeah.
Okay, so your u is an inside function, and we only mess with constants. Okay, those are the two things. Now, we're going to get into a little bit weirder. Lovely. Okay, so let's do, I like this one. I'm trying to find the top of the paper. There we go. Okay. And this would definitely be one I know, like somebody was saying to me yesterday, I don't remember if it was Caleb or Remy, I don't know, maybe it was Aiden. I shouldn't have to do this on all of them. You're right, neither do I. This is one where I'm not even doing this in my head. If it makes you feel any better about your life. I'm not doing this in my head. Okay? There's way too much in this for me to be like, yep, I got this in my head. I don't got this in my head. I'm about to tell you that's a lot to keep straight. Bless you.
I don't think I could.
Okay, so tell me,
Is that dx below or is it just?
it's just hanging out on the end.
-1.
So let me ask you this question. That's a -1. Or let me say this, like Lily asked this, is that dx below? The dx will never be below. It'll either be next to or on top of. Because it's like dx over 1. So it can't be on the bottom. Okay, so what is u? Thankful, in this case, I'm very thankful for parentheses. Otherwise, I'd be like, I don't know, what's the inside function? Okay, so be careful and tell me what is du?
1 over 4x.
Oh, no.
No, it's 1/4x dx.
Is it 4 over 4?
4 over 4x, which is what? 1 over x. Okay, so the -1, you guys, the derivative of -1 is 0, so that's not in your du.
Didn't we have this whole conversation that it's, if it's natural log of something with a constant, the chain rule was canceled?
Right, so this is 1 over 4x. We did have that conversation, but chain rule multiplied times 4, and those 4's cancel out, and it's 1 over x. So du is 1 over x. Again, there's no -1 in there. Okay, now, do you see, okay, do you see 1 over x?
I see 2 over x.
We see 2 over x, right? We see 2 over x, so what are you going to do? Either pull the 2 out front or multiply the 2 over here, whichever way it gives you the same result. Now substitute. Okay, what is the, I lost that. What's the substituted, is it called an integrand? What's the substituted integrand in terms of u? 1 over u. Yep.
Oh, so there's no x.
X is gone because that's substituted out, right? Because of the du.
It's just weird because that x isn't inside of the.
Yeah.
I know.
So why is it taken out?
Okay, because so this 2x here
Yeah.
is this 2x here.
Oh yeah.
Is that what you're asking me?
Yeah.
Okay. Now, what's the antiderivative of 1 over u? Yeah, natural log what? What?
Absolute value?
Absolute value of u?
So,
Yeah, that's weird, huh? So this would be 2 natural log absolute value of that u stuff, -1 plus natural log of 4x plus c. Like there's no way on earth I'm getting that without u substitution. Most of the rest of these I can do in my head, but not this. Nope. Don't even want to try. There's no way. I could maybe magic it up, but it would take me a little bit. Okay. So that's weird, but listen, if you follow the steps, you find the inside function, you see how to adjust it, then you can do it. Okay? So don't let the ugliness of it intimidate you. Why don't you try? Those are too easy, really. Nope. I want to do 2 more kinds and then I'll give you your homework.
Is it a worksheet?
I think it is. I don't remember.
When you give us worksheets, it's like the second coming of
It is a worksheet.
Miss Douglas?
Yeah.
Did we do anything other than this?
People always end up wearing the same sweatshirt.
Okay, now I want you to listen to me. This is weird because there's no parentheses. Okay.
Yeah, but
Also, it's okay. Why? Like, I love that statement. Why is it?
bottom is
Because it-
what?
Turn around, David.
The top is the derivative of the top.
That's right. Because the top is the derivative of the bottom. So do you see how it's looking for that? Because you know you're going to use substitute, you want to see a derivative. So you know the bottom is the inside function. Very good. Now go.
So basically, it's just always the one with the higher. That's
That's a long time. Always is a long time.
What if the bottom is the inside X?
It's a good indicator.
It's a good indicator, but at least that's a reasonable place to start.
So the top is a higher exponent than this.
You're assuming polynomials. It doesn't have to be a polynomial.
So you could, would you move this up and add your own parentheses? Or is there no point?
No, substitute first. Substitute first.
What if there's one of the things that you normally pull out there that's just like earlier in the C? You just gotta think about it for a while. Yeah, I know.
Say again?
What if there's something that you normally would pull out, like if there was like a 5 or something?
Yeah, with your
These are numbers are different.
Ah, bro, I get it.
You still would be like, wait a second. I know this would be an x to the 4. History would be, so he's, so you're basing it, I base it more on power to make the numbers in. Is that answer, is that what you're talking about, right?
Yeah.
No, I do get it. X cubed natural log of 4x.
Okay, we're gonna finish this, we're gonna do 2 more, and then I will give you your homework. Oh, you're welcome.
2 more, I thought this was one of the 2.
I changed my mind.
Do we need an absolute value? Yes.
Yep. Because this one is actually easier than I wanted it to be, but it's okay. Okay, what? Final answer. What's the final answer?
Natural log of absolute value, 4 to the 5th plus 3 plus C.
Correct. You guys, this one's nice because when you find your U, which just like I said, takes you thinking about it, right? And going, oh, I totally see the derivative there. It's all directly substituted. You end up with 1 over U, which is a nice derivative or antiderivative. Okay. So this kind of goes to the question. This goes to the question of, so you're always looking at the lower exponent. Whatever. And I said, quote, it won't always be a polynomial. Don't steal anybody's learning moment.
I was just gonna ask a question.
Is it going to steal somebody's learning moment if you ask it?
It might.
Okay, don't ask it out loud. Just a second. Okay? So I want you to think about it. You guys, you really just look in your head and you go, hey, if I do the derivative of the top, if I make that the u, what is the top going to be?
100 to the 5x.
100 to the 5x, but how are you going to substitute that in for u, right? What if you make the bottom u? What's the derivative of the bottom? Do you see that that's a significantly easier? So if you're in doubt, you go with what's easier. Go with what's easier.
could you technically do the?
You do it with the bottom and I'll do it with the top and show you what happens.
Okay.
I feel like you do it enough that you just divide it by that.
Well, you do that. You do the bottom, which is the correct way.
Well, yeah.
Okay.
So it's actually done doing that. Start, can I ask?
I've gone far enough, so yes.
I've had the inside.
Yep.
How do we know? Because the connected part.
Actually, before I was born, this problem.
So if you do that, if you were.
Seven was the one before you, so I think he's literally.
That's about the
So if you did the top, it just gives you the
Yes,
same
yeah.
thing.
Which is no way.
How many times do you think someone could do that before realizing that they? You like keep doing it, like.
But because this has a plus in it. Okay, if it was just that, then if it was just e to the x on the inside, e to the x we know is always positive, right? Then you could dump the absolute value. Okay. So, just to answer the question that we were talking about, like, what if you were like, hey, it's e to the 5x, because that's whatever. Look what happens. So e to the 5x, no problem. You can do the substitution, but you end up here. What are you gonna do with that? Yeah, me too. No, you can't pull a u out because there's no u. This is not multiplied. Like this is not. This is not. That's what I'm gonna say.
But you couldn't pull the U out of the top.
So if we start doing all these questions and we start getting things that don't make sense, we need to find a new u.
Pick a new u. Yep. Because look what happens if you pick the entire bottom, which is the correct thing. E to the 5x plus 3. And you know what? Honestly, Garrett said, well, how do you know it's the plus 3 and not just the e to the 5x? If you do just e to the 5x, you get what I got. You don't want to do that. So the whole thing, because then you can get rid of the whole thing and you have just a u on the bottom. So if you have a u to the something solid on the bottom, usually it's something, I'm going to be careful saying this. Never mind. I don't want to say this.
Do the rules apply differently in different scenarios that they don't know yet?
I'm sure that I could always say that. But this is 4 1 over u du. So you end up with 4 natural log absolute value e to the 5x plus 3 plus c. So I want you to think about when we do the derivative of a natural log. So derivative of a natural log, it's always 1 over the x thing, right? And so the chances are that when you see the thing on the bottom, if you're going to have a natural log in your antiderivative, it's the whole bottom, right? Because it's 1 over the x, the whole x thing.
Generally speaking, shouldn't we start with the thing that has an addition or subtraction in it? Because when you take a derivative, that goes away.
That's another reasonable.
Always is a long time. The same. Like generally, shouldn't we start looking at that one?
I mean, if you're not sure, if it's not obvious, that's another good thing. You know the derivative of that's going to go away. Okay, last one. Question, Mason?
I was just thinking if the natural log and e made things cancel, but I don't think it.
That's what I was just talking
Okay,
about.
so-
Sorry.
Go ahead.
Because the 3 is there, it can't be applied. It has to be a standing alone.
Is the absolute value also an issue?
So two issues. Okay, so the absolute value is an issue. Nope, not the exponent. Absolute value is an issue in the plus 3. So let's say though, this is not related to this problem. So let's just say in general, you were doing something like this. Okay, absolute value is still an issue. However, e to the x, what do you tell me about e to the x?
Positive.
Always positive. So you can then eliminate the absolute value and then it cancels.
Well, we can get rid of the absolute value on that one too, can't we? Because e
Yeah.
to the x is always positive and plus 3 is going to make it more positive.
Yes, but if you do that, then it still would have parentheses and you can't cancel because of the plus 3 still. We're back to that problem. Okay, last one. That's a -3 plus natural log x running onto that line there.
But you cancel that if you apply a natural log to the 3 too.
No, because natural log does not distribute.
Oh. It doesn't, okay.
Because you can only do it of a value, you can't like say times this by natural law.
Right, because it's not a number.
You have to say natural log of a number, so you can't just be like.
Correct. That's like, because like functions don't distribute, like sine doesn't distribute.
Yeah.
Square roots don't distribute. Square root of a number. So like,
I thought you had like this like sine.
no, just a second. Like,
5 is tripping me out.
Because if it distributed, then you
like
can
this is not distribution.
But if you had like sine of x and then another.
You absolutely, if it, absolutely, if sine of x distributes,
Yes, 'cause
sine
that's
itself
already-
does not distribute.
Yeah.
It's not, you couldn't change that to like sine x
Yeah.
What's
plus
the limit of stuff I can mess
sine
with here? Because is this correct or should I include this in here?
No, the 5?
Yeah, the 5e.
No, because you want the inside function, right? So 5e is not inside.
So can I pull 5e out to the front or is that?
E is not E, because it's the base. Substitute first, and then ask those questions. I promise. Substitute first before worrying about what to pull out.
But I don't have a 1.
-3 plus natural log
I do.
x.
Look, this is, here's 5, right?
Yeah.
Always 5 times 1.
So then
I suppose, but that doesn't seem to be.
1 over x.
Substitute, do the substitution. Promise it'll work. Just
And
keep going.
then out front.
Trust the process.
Trust the process,
Take
indeed.
take the
I promise it'll work, and it's actually
out front
really
becomes
easy.
5e, right?
Yep.
Which would be stupid, but yeah.
And
Yes?
So it's e to the power of natural log of x, but there's stuff in front of it, so does that cancel out the property of that, like turning into something? Because e to the natural log of x, what does that turn into again? That's
X.
x, okay. But because of the -3.
Did we not literally just?
Okay.
We did.
Joe, it was slightly different.
Does it become u over
Oh,
one?
you're still working?
What?
Especially.
Okay, so question,
I mean, it was the last thing we just talked.
it is, what is the u here?
The exponent.
Is the exponent. So one reason I wanted to do this one is so that you know it's not always just automatically the bottom, right? You still have to look for that inside function. But if you are here and you're like, I don't know what the inside function is, it probably is the bottom. Okay? If there's not an obvious inside function and you're like, I don't really know, try the bottom. Okay? That's what I would say. What's the antiderivative here? Or I'm sorry, what's the derivative?
1 over x is dx.
Okay, now, Lily said to me, I don't have 1 over x. True. However, isn't this 1 times 5? Okay, so there's the 1. So then when we substitute, we have 5e to the u du, and get rid of the 5 if you don't like him there. Okay, well, I'm putting them out in front.
Oh, so we can just get rid of the bottom.
Because 1 over x.
Yeah, I don't know.
1 over x dx.
U over 1.
Okay, so then your antiderivative of e to the u is
E to the u.
e to the u. So it's 5 -3 plus natural log x plus c. And you're done.
Oh yeah, the e just stays in.
Yeah, it was. But so listen, before, let me say this, before you freak out, you're like, this isn't gonna work, at least get all the way substituted. Okay? And then determine, okay, this isn't gonna work, right? Like, here's where I go, that was not a good choice.
If I ever taught you substitution, I would.
So substitute.
It was called Q substitution.
Q substitution. Alex, what's your question?
So I said,
Hey, please be quiet.
So I pull out 5, but since it's 5e, wouldn't the antiderivative still be 5e?
Yeah. So you can pull it out or not pull it out.
Yeah.
That's fine.
Does that only applies to t?
If that was, like, if we were doing,
Stay the same.
if we were doing the antiderivative of 3 cosine x dx, I can pull that out or keep it, right? Constant multipliers just stay. So if it's worth your time and energy to pull it out because it's bothering your brain, pull it out. If you don't want to pull it out, don't pull it out. Okay, there you go. That's what I said about that. Okay, I'm not making you do all of these. So number one, don't lie to me. Number two, give me a second and I will start crossing the things off. Oh, I just lost.
That's a lot of papers.
Okay, couple things. What does it say?
I didn't even know you had that.
Yeah, I'm not gonna lie.
We've had this class for 2 years.
Yeah. It's been I got it for Christmas last Christmas, year and a half ago. Okay.
More you know.
Couple things. I printed this off on my worksheet generator. Look at number 5. I really don't like the way they do this. Okay. That's not sine minus 4. That is sine of negative 4x. Okay. If it was me, like on a test for you, I absolutely would be putting that in there, but they did not put it in there. So there's a couple of those. Flip the paper over. You see that thing again on 14, 15, and 18. Okay, 14, 15, and 18, that's that same issue with the negatives. Now, I'm not saying you have to do all those. On 14, yep, it's right there.
So
So what's our inside function?
Well, I'm not, just wait. On 15 is negative x's, and then yes, 18 is negative x also, like that.
the reason they don't include parentheses is because you know you have to have
An x as an argument with this secant, correct. Okay, so let's see. Everybody, you can cross off number 1. Everybody can cross off number 1. And number 3.
And number 6 through 18. Sounded like that idea.
7 you can cross off.
I agree with you, but we will start. Don't even get me started on
You can cross off 12. Let's see. You can actually cross off 13. 16. This really hurts my brain with that there. It bothers me. No.
What hurt your brain? 15.
You can cross off 18 also. Okay, now, so that's everybody. That's everybody.
No, now she.
Oh, okay.
Okay, everybody. So you got that? Anybody need me to repeat that? So you actually have 1, 2, 3, 4, 5, 6, 7, 8, 11. I think you have 11 questions, which is much better than 18. Okay, now if you're Gold Star Club, you may cross off 2. You can cross off 6. And 17.
Sweet.
You know I just crossed off the easy ones, right?
Yeah,
Okay.
but I got 2 really hard tests.
Mm.
Mr. Smith's and Miss Page's.